Take it away. Take it
well,
away.
Chosen well, chosen well. Yeah, my name is Jörg. I'm representing TEGnology, and we identified a challenge in the industrial IoT that goes down to the very simple task of actually powering the sensors, as we heard before. What is going on in the industry is that we have more and more devices connected. Also in large-scale industrial parks, large distances have to be bridged. And the challenge that the industry is seeing there in order to implement the sensors and to generate data in order to optimize processes is that things preferably should be wireless. And if you go wireless or real wireless, because cabling is not a suitable solution for these large distances, you end up mostly with batteries. So we claim that the battery have a challenge, and that thermal energy harvesting actually is an answer to that challenge, and that thermal energy harvesting might be the piece in the concept of powering sensors in order to make the digitalization happen. And the challenge is the cost of ownership, actually, so not the battery price as such, but changing the battery. So we had heard some numbers before. Many batteries, 28 billion per year are replaced. And what we found in customer input is that replacing a battery, for instance, in a smart building, I mean, not like going down the basement and finding a new battery, but professionally replacing a system in a smart building already costs around €100 per sensor system. And every time you change that battery, if you go into the industry, the numbers rise to €1,000 per sensor system. And if you have to close down the process actually in order to make it safe enough to change a battery, you end up with numbers in the range of €100,000 per hour and above that. And then also related to that the batteries in the really harsh environments of the industry are not feasible. So yeah, as we heard, high temperature as well, but also moisture, vibration, and things do limit the batteries in the usage. So our suggestion is, as said, the thermal energy harvesting. That means we have the hot side of a pipe, of a machine, and we need a cold side on our device. You can see here our power supply. And then we have materials inside the device that convert this heat delta or this difference in temperature into power. And by adding some low power management, ultra low power management, we get a regulated output that simulates more or less a battery. So you get your 3.3 volt output to power sensor. You get from that a functional device, a power supply that works at high temperatures. It works at humidity. It is not really sensitive to dirt because you can encapsulate it completely. You don't have to change anything. It is resistance against G-forces. You don't have any contacts that could open or close. It works, of course, in darkness, and compared with solar, in sunlight, and compared with solar, it also works, of course, in darkness. So we have a real game changer. You don't have any compromise any longer on the battery lifetime. So instead of only sending data like once an hour because you want to have like 2 years battery lifetime, you could send every minute. Because you have sufficient energy available. It enables sensors in hard to reach places. So you actually get the data that you're really interested in. Sorry, one back. The cost of ownership is reduced to a minimum. You don't have to change any batteries. And also the planning and installation costs compared to cable or wiring is of course very low. So what TEGnology is doing is that we have state-of-the-art TEG technology, which is like the generator in the device. We have there actually a patented product now ready that is flexible and has no rare earth metals, which makes it rather cost efficient. We combine that with advanced low power, ultra low power management, and that results in the SenseEver product line. And there we have so far 2 products: the power supply in the bottom, as you can see, as I discussed before, and also a safety device that is a hot surface indicator that is simply blinking when the pipe is hot and not blinking when the pipe is not hot. So what we can use it for you can't see anything here, but this is a production line, and actually there is also a device mounted, and that is the SenseEver HSI, the hot surface indicator. And the reason for this device is here on this pipe is that this valve here in the top needs to be changed by some service people, and the service people accidentally touch the hot pipes during when they do that and get injured by these hot pipes. And this is actually up to 15% of the injuries, some customer that we talked to. So they have installed this hot pipe indicator and indicate the pipe is hot or not. They can also use it for monitoring the process. So in this case, the light is blinking when the process is running because it's hot. Usually they touch the device in order to see whether the process is running. For the Alpha is much broader. For the application, you can power more or less everything that is battery driven. In this case, the AirThing Wave Plus, which is a device for measuring air quality. We have the Kamstrup heat meter, where you have the opportunity to power it by battery. This we also connected to our SenseEver Alpha and drive it just by connecting it to the hot pipe here, our SenseEver Alpha, making the battery obsolete. Then we took some Phoenix sensors that is a Bluetooth sensor measuring pressure and temperature, and is connected via Bluetooth to an app. Also here we replaced the batteries by connecting our device, and it can be powered for forever instead of changing the battery every 6 months. And also we have an application in the heat exchanger market where we have connected a monitoring system to measure temperature and pressure. And in this case, we could actually not only replace the batteries, but actually also increase the data rate by factor 10. So the product market fit is clearly where cables, for instance, are not feasible due to high planning costs, high installation costs, and the monitoring on rotating parts, for instance. And on the battery side, we fit to the applications where the battery is not feasible because we need more data points. The harsh environment is prohibiting use of battery. And in some cases, also companies have an environmental strategy saying that they don't want to use batteries simply because of the environmental impact. The feedback is great so far. We have Alfa Laval, who's very interested in having autonomous sensors. Develco is a development house you might know all, which sees actually in this technology potential for driving force for new projects. We have a German customer where we enabled a gateway instead of having a 2-month battery lifetime to have it like always on. And Novo Nordisk is very happy about our safety device, this hot pipe alert. And of course, luckily we also won some prizes. IoT Solution World Congress in Barcelona this year, we won a startup pitching. And now recently we won last week actually the Startup Germany Tour, or we got a sustainability prize there for our technology. So we made quite some noise for the past year. We run around with this concept for 1.5 years, and we hope to convert the people and make them rethink power supply for IoT. And to finish my presentation, I borrowed a statement from Steve Jobs and changed it slightly. So do you want to change batteries for the rest of your life, or do you want to join us and change the world? Thank you very much. That's it.
That's great. That's great, Jörg. You know, I was at Apple when Jobs were there, and I think your quote was better actually then.
Yeah, thank you.
Excellent. I have a question for you on the chat. Is the size of the sensor unit an issue from the customer point of view?
This is the size, and usually it's not. But if it is, we can redesign this device. I mean, the active unit inside is actually only 2 to 3 square centimeters in area, and so if there is some size restrictions, we can change the size, of course, and make it a customized version. We can also integrate sensors, so we have a lot of background in IoT itself. So instead of like using this cable, we could integrate a sensor unit measuring whatever needs to be measured on the device. But it depends usually also on the temperature delta that you have, the difference that you have, whether you work with only 10 degrees, 20 degrees, which is also possible, or whether you have really a hot machine, hot pipes of 120 degrees.
Super. I don't have any more questions for you on the chat. So can you say anything about where you are when it comes to investments and things like that?
Yeah, we're looking for investors right now. The guy to talk to is our CEO, Hao. But we have plans to get some investment in place next year. So if there's interest, we are very interested to talk and to discuss.
Super. Well, with all of that, thank you so much, Jörg. Good to have you here.
Thank you.